in the grand history of the cosmos on Earth is replicated elsewhere. There's another you out there.
What if I told you that right now there could be another version of you watching a completely different video? Or perhaps reading a book. Maybe you chose a different career, or maybe you never even existed. This may sound like a plot of a sci-fi movie, but some of the smartest scientists on our planet believe that these parallel realities might actually exist. The multiverse theory is one of the most mind-bending concepts in all of physics. It suggests that our universe might not be the only one. Instead, there could be countless other universes existing alongside ours. But where did this idea even come from? It all started with a mystery. In the 1980s, scientists were trying to understand why our universe looks almost identical in every direction. The answer they came up with was a theory called cosmic inflation. The idea that right after the Big Bang, the universe expanded at an incredibly fast rate, even faster than the speed of light. But then, something unexpected happened. Their calculations showed that inflation wouldn't create just one universe, it would create an infinite number of them, constantly branching off from one another in a never-ending chain reaction. This was the first big clue that led to the idea of a multiverse, but it wasn't the only one. String theory is a scientific idea that says everything in the universe is made up of tiny vibrating strings, instead of particles like atoms or electrons. And the way these strings vibrate decides what kind of particles they become, what their mass is, and what charge they carry. The theory also suggests that there are more dimensions than the ones we know. Besides the 3 dimension of space and the 4th dimension of time, there could be 10 or even 11 dimensions. These extra dimensions might be shaped in special ways, possibly creating completely different universes. In fact, string theory predicts that there could be around 10 to the power 500 possible universes. That's a 1 followed by 500 zeros. For comparison, the entire observable universe has only 10 to the power 80 atoms. Even if each atom were its own universe, we would still be nowhere near the number of possible universes predicted by the string theory. Another idea of the multiverse comes from the quantum mechanics, the science that explains how tiny particles behave. At the microscopic level, things don't work the way we are used to in our everyday life. Instead of having just one fixed outcome, certain events can have multiple possibilities. Quantum mechanics suggests that every time such an event happens, the reality splits, creating different versions of the universe for each possible outcome. This is known as the many worlds interpretation. For example, imagine rolling a dice. In our world, we can only see one result, like getting a 6. But according to the many worlds interpretation, in another universe, you rolled a 4 or a 1 in another. Every possibility exists somewhere all at the same time. While this idea might sound a little crazy, it actually helps the scientist explain the strange behavior shown by the tiny particles like electrons, which seem to exist in multiple places at once until they are observed. Be it the cosmic inflation, string theory, or quantum mechanics, none of these theories have been proven yet. But they do make us wonder, could there be other universes beyond our own? And if they do exist, what would they actually be like? The other universes, if they do exist, might have totally different laws of physics, making them completely strange and unfamiliar to us. In our universe, 4 main forces control how everything works: the gravitational force, the electromagnetic force, the strong nuclear force, and the weak nuclear force. Each of these forces have a specific strength measured by special numbers called physical constants. These physical constants decides how the universe behaves. If even one of them were slightly different, our universe could look entirely different. For example, if the strong nuclear force were just 2% weaker, atoms beyond hydrogen wouldn't even form. That means no chemistry, no complex molecules, and certainly no life. If the gravity were little stronger, stars would burn out too fast for the life to evolve. And if it were weaker, galaxies wouldn't even form. This brings up one of the biggest questions in physics. Why does our universe seem just right for life? The chances of having perfect conditions for stars, planets, and living things to exist are so incredibly small that some scientists find it very hard to believe. It's as if someone perfectly adjusted the settings of the universe to make life possible. This is called the fine-tuning problem, and the multiverse offers a simple explanation for this. If there are infinite universes, each with different laws of physics, then it makes perfect sense that at least one of them would have the right conditions for life. We exist in this universe not because it was made for us, but because we couldn't exist in any other. This idea is called the Anthropic principle, and it sparks a lot of debate. Some scientists like it because it solves the fine-tuning problem in a simple way. Others dislike it because we still don't have any proof that the other universes actually exist. The idea of infinite universes sounds amazing, but can we ever find any actual evidence? Well, maybe we can. If the multiverse does exist, different universes might have crashed into each other just like the galaxies do in our own universe. And if our universe had ever collided with another universe in the past, it might have left a unique pattern in the cosmic microwave background. Scientists have been actively searching for these patterns, but so far they haven't found any conclusive evidence. Black holes might also help to prove the existence of the multiverse. Some theories suggest that falling into a black hole could take you to another universe. This idea comes from Einstein's field equations, which allow for the possibility of white holes. White holes are the hypothetical opposites of the black hole that push matter out instead of pulling it in. If this is true, black holes could be an entrance and the white hole in the other universe could be the exit. Stephen Hawking also supported the idea of black holes being the gateway to the other universes. According to him, black holes slowly evaporate over time by emitting radiations now known as Hawking radiation, and if given enough time, it might disappear completely. This leads to an information paradox. If the black hole completely disappears, what happens to the information about everything that was absorbed by the black hole throughout its lifetime? Some theories suggest that the lost information might leak into another universe rather than being destroyed. And if we can prove this, it would be a strong evidence for a multiverse. But so far, no one has ever seen a white hole and no one knows what happens to the information absorbed by the black hole. Despite all these compelling maths and theories, we still don't have any solid, undeniable proof that the multiverse exists, and some physicists believe we may never find any evidence since these other universes could be forever beyond our abilities to detect them. So what do you think? Is the multiverse one of the most profound ideas in physics, or just a crazy mathematical concept? Let me know your thoughts in the comment section below, and if you enjoyed this video, don't forget to like and subscribe for more. I'll see you next time. Till then, keep exploring and stay curious.